we are going to introduce now Ampere's law, and, well, it's a line integral. We'll see that in a moment. But we're first going to take a short digression, and you'll see why in a moment, that our digression is going to go back and just remind us of conservative fields, conservative forces, conservative fields, and how that was done. And we've done enough of it at this point. I think just a quick reminder will do. So if we recall for the electric field, right, if we looked at the work done on a positive charge, let me zoom in here. So we're going to look at the work done on this positive charge as we do a complete closed path. So when we start at this point and we move around any closed path, the work done by the electric field will always be 0. So that's when we do F dot ds. So F is QE. I'm going to sneak the Q in here for a moment, but I'm going to erase it as well. So when we do the work done, QE dot ds, F dot ds, we will get 0 when we go around any path, because when we go downward, when our ds, let me use green for ds here, anytime our displacement is downward, the electric field is working with us. Anytime we go back up, the electric field is going to work against us, cosine of 180. So round trip, they will cancel out. And any side-to-side motion that we do would be cosine of 90 degrees in our dot product over here. So that would give us 0. So it is always 0. The electrostatic force is a conservative force. And of course, the electric field is conservative. We say it's conservative because the Q can come out of the integral. It's constant. 0 divided by Q is still 0. So the electric field is a conservative field vector. So let's erase that. Or we can leave it. We'll leave it in. I guess you can either put it in or not. And the top part that I have here is just a reminder of the first time we saw conservation. It was with gravity. Same deal. Gravity works with us and against us to cancel out. Sideways, horizontally on gravity doesn't affect the work being done by gravity. So we could say the M comes out. So the G vector is our field vector and would be our conservative field vector in gravitation for constant universe or constant gravitational force near the Earth. Now, what's the situation with the B field? Well, let's do the same thing where we're going to calculate B dot dl around a closed path where we're going to start and end at the same point. So let's do it. So let's start here and take a look at calculating B dot dl. Well, B dot dl, let's get the B vector first. So if the B field is being made by a long straight wire coming out of the page, so that's what we're taking here, that the current is coming out of the page, so put your pencil perpendicular to the page, sticking out of the page here. Go back and just do a quick IDL cross R hat, thumb to the left. So the B field vector is going to be tangent to that point and pointing to the left. Well, the ds we are taking to be a circle. Now, it's just this example, but any path, any closed path will give us the same answer. In this case, I am choosing the ds to be this circular path, and the ds will also be tangent and parallel to the circle. So we get cosine of 0 for the angle between the B and the ds. And that would be at every point. So at this point, at this point, at this point, you will get that always. Well, we know the B field outside of the long straight wire from our previous notes is mu naught I on 2 pi r. And that's constant, right? So the I is constant, and we're taking our path to be constant. So the B comes out of the integral, so constant R. So make sure you get all of this in your notes. The B comes out. We're left with the integral of ds, which is s from 0 to 2 pi r. So when we calculate the answer to this integral, we do not get 0. B is mu naught I on 2 pi r. The 2 pi r's cancel, so our answer is not 0. It's mu naught I. So B is not a conservative field vector. And we'll see in our next lesson that this actually turns out to be Ampere's law. But the most important thing you need to know about this lesson and what we're emphasizing is that when you do integral B dot ds around a closed path, you will never get 0. You will always get mu naught I, and the B is not conservative. And we're going to talk more about this in our next lesson.